Welcome to Brain Vision.
This is the problem number 6, and this problem states that y cannot use integration by parts directly on the middle expression in the equation 1.29 and pull the time derivative over onto x, and note that delta x by delta t is equal to 0. So then the equation 1.29 is, that is, time derivative of expectation value of x is equal to minus infinity to plus infinity x and del by del t mod of psi x t square and dx, and this equation is also written as I h bar by 2m minus infinity to plus infinity x del upon del x, sorry, this is del t, and this expression is psi del psi by sorry, this expression is x uh, del x minus del psi by del x and psi and dx, and this that is middle expression, that is this expression cannot be done using the by parts, because the integration here, because this is the time derivative and this is position derivative. So here this is integration with respect to the position, and the here the this derivative is the time derivative. So that means here there are two variable, that is time variable and the x variable. So we cannot do done this by parts, because integration, this integration dx and the derivative, that is del by del t, taking with respect to different variable. That means it takes with respect to t and it takes with respect to x. Hence, we cannot uh, done this integration by parts. So if we do this by part, then it will be x del by del t. So that we cannot, because it is a time derivative here. So we cannot integrate by parts here. This is the reason why we cannot integrate this by parts, because of different, because of different variable for integration and uh, derivative. Here integration is with respect to x and the time derivative with t. So that means they are at different variables. So we can, if the variables are same, suppose we are integrating this term with respect to x, and this del by del t is replaced by the del by del x, then we can do the integration by parts. And the next part of this question is second part. Pull the time derivative over onto x. Note that delta x by delta t is equal to 0. So it is given that del x by del t is equal to 0, and then we conclude that derivative of this x is equal to 0. Let's prove this one. we have, that is del by del t and x of psi mod of square, and this is the middle part, that is this part, and here it is going to pull the time derivative over x. So that means time derivative over x. So we have pulled this x inside this del by del t. Then we do this by part, that is del x by del t and mod of psi square plus x, and the derivative of this, that is del by del t and mod of psi square. So here it is given that del x by del t is equal to 0, that means it is 0 and plus x del by del t mod of psi square. And if I integrate this on both sides, that means minus an x del by del t mod of psi square and dx is equal to this minus infinity to plus infinity del by del t and x mod of psi square and dx, and it is not equal to, because here this is the time derivative and this is x, it not equal to, that is x mod of psi square. That means this d by dt of this, that is time derivative of this expectation value is 0, because we write this equation dy dt of x is equal to minus infinity to plus infinity and x del by del t, uh, uh, okay, this del by del t mod of psi square and dx, and the value of this x is equal to, is not equal to this, or you can say that because this is the probability density and because it is constant, hence the value of this will be 0, hence this whole value will be 0. So this value is 0. Thank you.